Hello and welcome back for another VMK in the C++ series. In this VMK I'm going to discuss how to use the enumeration data type as well as how to use the switch statement. Both these items are used in conjunction together to simplify logic flow and make your code a lot more readable. Let me demonstrate how this works. We're going to go into Visual Studio here, create a new project, and I'm going to create a Windows 32 console project, and I'm going to call this Enum Switch. Under Application Settings, I have console application selected, and then everything else is not selected. This gives us a simple project to work with, and let me demonstrate first how you would replicate this sort of functionality using a standard if-else statement. In game programming or any other kind of programming, you may create a variable that is used for a number of decisions to be made. So let's create this variable here called iValue, and depending on what this value is, we're going to want to print something different on the screen. So you may create something like this: iValue equals 0. We have printing. We print to the screen sleeping. If the value is 1, let me change this here. If the value is 1, then we want to display walking. If the value is 2, then we'll display running. If the value is 3, we'll display hiding. If the value is 4, we'll display shooting. And then if it's any other value than these ones specified up here, then we're going to just display unknown. Alright, let's try this program out. You can press Ctrl F5. And we have some build errors here. We've missed the bracket here. I put a curly brace in rather than a regular bracket. Alright. And we also forgot to put a carriage return at the end here. To fix that, we can just type in a carriage return right at the very end here, like so. Okay, so right now it's displaying sleeping, and sleeping is equal to 0. So if we change this to maybe 3, then now it's displaying hiding, and sure enough, hiding is value 3. So you notice that depending on what this value here is, we display something different on the screen. Well, you can see that there's a little problem with this. If you were to hand this code off to someone to use, they need to know what these values here represent, because they may not be able to actually see this code. It may be hidden from them, but they're asked to update iValue so that it changes the behavior of something in a game or your program. Well, this isn't really ideal because the user needs to know these codes. And the codes could get really archaic, like we could have thousands and thousands of values here for thousands of different kinds of outputs. So you don't want to try to remember all the different kinds of codes that represent all the different kinds of things. There is a better way to handle this. To start off, we can replace our if statement here with a switch statement. And the switch statement behaves just the same as the if statement in a way, where we can say we're going to switch based on iValue, and if iValue has a case of 0, which means if it's equal to 0, then we're going to display sleeping. If it's 1, then we're going to display walking, 2, running, and so on, all the way down to 4, shooting. Otherwise, if it's none of these, we're going to go into the default case where we're going to display unknown. Let's try this out. Right now we're displaying hiding, which is value 3. And if we scroll down here, we see case 3 is displaying hiding. Alright, let's change this to 10. This one is unknown because it's not one of the numbers from 0 to 4. So we go into the default statement and we display unknown. This is good. Now, the added flexibility that we have with a switch statement is that we can actually cascade our logic. So for instance, if we know that every time that you're hiding you also want to be shooting, all you need to do is remove a break statement like so. And the order that you place your case statements in here will depend on the output that you'll get. So now what will happen is, if we type in a value of 3 here, this means that the logic flow is going to go into a statement, It's going to go into our case here, display hiding, but because we didn't break out, it's going to go and execute the next guy through. And it's going to continue going through all these case statements until it finds a break. But because we only have case number 4 right after case 3, and then there's a break, we're going to display hiding and then shooting. So let's see that work. So here we go. We have hiding and shooting, one right after another. If we change our value to 4, this means that our logic will go straight into case 4, and we're just going to display shooting, like so. So with this case statement, we've now created a structure that lets you flow from one case to another depending on if you add this break statement or not. Usually you want to have the break statements, but under special conditions you may want to remove them depending on how you want your logic to flow. Now this still has the problem of the users need to know what each of these values represent. You need to know that 4 really means shooting, and you need to know that 1, for instance, is walking. But again, there is a better way to handle this, and this is using the enumeration data type. What we can do is right at the very top, we can create an enumeration by using the keyword enum, and we're going to call this enumeration action. This action is going to have the following behaviors. You can sleep, you can walk, you can run, you can hide, you can shoot, and then we also have unknown. Now notice that each of these enumerations are actually represented by a value. An enumeration is a fancy way of representing an integer data type. So sleeping has been set to be equal to 0, and then everything after that is just incremented by 1. So walking is a value of 1, running is a value of 2, hiding is a value of 3, shooting is a value of 4, and then unknown is a value of 5. So now using the enumeration, what we can do is encode our commands using the action keyword. The way we do this is like so. We can define a variable to be an action. And here I'm just going to say my action. And I'm going to specify my action to be equal to something. And the way I make it equal to something is I just specify it like so. So now I'm saying that my action, this is the name of my variable, is going to be equal to running. And inside of our switch statement, I can just pass in my variable, which is called my action. And now, notice that our code runs perfectly well. We have our action set up to be running, and we display running on the screen. This is a good start. However, we can take it one further step. Instead of representing all of our case statements here as numbers, we can replace them with the actual values from our enumeration. So let me go ahead and do that quickly. Case 1 was walking, case 2 was running, case 3 was hiding, case 4 was shooting, and the default case was unknown. Alright, so now notice how much more easy it is to understand our code. We have an action which we define to be a certain value, and it's easily readable because we specify it in words rather than numbers. Our switch statement switches based on a variable, which is an enumeration, but our enumeration cases are easily readable as well. So now you can see if our action is running, it's going to display the following. If our action is shooting, it's going to display the following, and so on. So our code is now so much more easy to understand because we don't have these numbers coded within our program to represent different things. Instead, we're using words to represent those things that the computer is trying to understand. So let's just go and try to run this one more time. I'm just going to set this up to be hiding, for instance. Compile it and run it just to make sure, and sure enough, it does work. So there we go.